and welcome to the BIS. Thanks for being here. My name's Colin Philp, BIS President. A bit of housekeeping before we begin. We're not planning any fire drills, but if there is one, there's a fire at the back, and we leave at the front of the building, which is the door that you came through, and we turn left out of the front door and go to the entrance of Vauxhall Park, which is about 77 paces in that direction. If there's a fire at the front, we leave from the back door, which is turned left out of the doors in this room, through another door into a courtyard, out onto the street, and again to Vauxhall Park entrance. We've got two talks tonight, which are a bonus, two for the price of one. We're going to start with Grif Ingram, who's the Associate Editor of Journal of the BIS, who's going to talk about the history of the space station for around 10 minutes or so, followed by Jerry Stone. So we have an excellent lineup. Most of you will be very familiar with our two speakers here. Jerry is a BIS council member and a spaceflight presenter. So without more ado, I shall hand over to Grif. Grif.
Oh, thanks everyone. Happy World Space Week. And the theme for it this year is living in space. So I thought I'd show you about the development of the space station concept. Now, the earliest portrayal of an inhabited Earth satellite that I know of is The Brick Moon by Edward Everett Hale, in a story published in the Atlantic Monthly in 1869. It was intended to act as an aid to seaborne navigation. It was to be launched by rolling it down a track and flipping it up at the end. I haven't done the math, but I don't think that would work. Now, in the story, during a banquet held aboard the Brick Moon to celebrate its completion, the satellites accidentally launched with guests aboard, and they later signalled to their friends by jumping on and off the thing in Morse code, but they're very happy in their little space village. But the first serious scientific speculation on space stations was by the father of astronautics, Konstantin Tsiolkovsky, and he conceived of a structure that's actually rather like some of the space colony concepts of today. There's a forest for air conditioning in the centre. I suppose it could be an orchard as well. Light emitted by that huge window at the end. You can see living quarters underneath it. It spins for artificial gravity. Workshops up at the other end, near that docking fixture for spaceships. Now, the first use of the term space station was by another pioneer, Professor Herman Oberth. And this is mentioned in the April 1930 issue of Air Wonder Stories. Now, that cover image is not a space station. Someone had the idea that flying buzzsaws would be a great way to defend the United States from aerial attack. But in this editorial by Hugo Gernsback, the father of science fiction, whose name is still immortalized as in the Hugo Awards for science fiction, he mentions that Professor Herman Oberth has been referring to Professor Herman Oberth, perhaps the greatest authority on interplanetary space, points out many uses for such revolving space stations, as he calls them. And he mentions in that editorial that such stations, equipped with telescopes, could observe weather patterns and the movements of aircraft. Sticking with the pulp magazines, this is a descendant of Air Wonder Stories, Science Wonder Stories, which serialized Captain Hermann Nördung's book on space travel, in which he came up with this space station design. What we're seeing there in the cutaway view is what he called the Wurmrad, or living wheel. It's got that big parabolic reflector there for providing electrical power by sunlight heating up a working fluid in a boiler and putting it through turbo generators. The big mirrors on the outside and heat into the living quarters. He was afraid of the bitter cold of interplanetary space, which he was wrong about, but never mind. Up on the upper right of that illustration, you can see the actual power plant, and on the upper left there's an observatory, and there's a nice young 1920s couple there observing with dark glasses. Now this design influenced our own Ralph Smith and Harry Ross later, which we'll get to in a bit. Now this is, during the war, a radio engineer named George O. Smith wrote a series of short stories in astounding science fiction, and anybody who's familiar with science fiction will know why I said that reverently. about this space station called Venus Equilateral in the Trojan position, 60 degrees ahead of Venus in her orbit. The purpose being to relay radio signals around the solar system at times when the sun was in the way. It was about the size of a modern space colony. It was supposed to be 3 miles long and 1 mile in diameter. It had to be that size to provide a steady platform. It was technically accurate according to radio technology at the time. Those red spheres there are antennae, and the reason for that transparent dome is there's trained observers in there using telescopes to keep the beams on target. Now this collected edition had a foreword written by Arthur C. Clarke, who said that at the same time he was developing GCA, George Smith was working on radar proximity fuses for anti-aircraft shells. He mentioned that shooting them out of guns is not generally recommended for sensitive electrical equipment. But now, during the end of the Second World War, Arthur Clarke published his seminal paper in Wireless World in the October 1945 issue, Extraterrestrial Relays, in which he invented the concept of the communications satellite. He pointed out 3 satellites, spaced equally around the 24-hour orbit, could relay signals around a globe. This illustration here is by Bruce Cornwell, one of the Dan Dare artists. It's from a book that some of Arthur Clarke's very short stories about the building of a communications satellite were serialized in. It was called Stirring Stories for Boys, with all that implies. They seem to be trying to handle 1/3 of the communications traffic of the planet with 1 antenna. Good luck with that. And this was the Ross Smith space station, published as a paper in, I believe it was 1950, of the Journal of the British Interplanetary Society, called Orbital Bases. You can see that huge parabolic mirror there for focusing sunlight on the boiler pipes. You can just see, this is the best illustration I could get, where the docking chamber is de-spun for a ship to dock up with, and then re-spun up to dock again with the living quarters. Now, the design which really established in the public mind the image of a space station as a space wheel was this. In Werner von Braun's series in Collier's magazine in 1952 called Man Will Conquer Space Soon. You can spend hours finding every little detail in this, but due to the popularity of that series, it established the idea of the space wheel as the proper shape for a space station. The still on the right's from the film The Conquest of Space by George Powell. I think you're supposed to, you were towed behind that little space sled there to get across to it. I prefer the idea of docking, it's much less exciting. And this was a design which graced it was either the first or second issue of our magazine Spaceflight. This is where Harry Ross revised the design to bring it up to date. Instead of the huge parabolic mirror, that's a mat of solar cells. This illustration comes from a book called Project Satellite, edited by Kenneth Gatland. We've got it upstairs in the library. And you can see an image of the station actually out in the lobby over by the window. Now, this is the manned orbiting laboratory contemplated in the 1960s by the United States Air Force. They've wanted military space for a while. This is part of the so-called Blue Gemini program. The whole thing was launched with astronauts in that Gemini. They're supposed to enter the laboratory section by crawling through a hatch in the heat shield. For descent, they're supposed to seal it up with epoxy adhesive. I wouldn't trust it. Despite the term laboratory, which is intended to sound innocuous, it was actually a manned spy satellite. They were supposed to take photographs of things and develop the film. Good luck trying to do that while you're weightless. Now we finally come to the original wet workshop concept for Skylab. They would launch the thing complete with propellants in that S4B stage. As soon as it was in orbit, the astronauts were supposed to dock, crawl through a hatch, vent the remaining propellants, and fit the thing out as a space station from inside. Again, good luck with that. They finally decided to launch it as a gutted stage. The oxygen tank was used for the garbage disposal, and the liquid hydrogen tank was the actual workshop. You can see that that structure over to the upper left looks like the top half of the lunar module with something bolted on the end. That's because it was. This was all part of the Apollo applications program. It was supposed to be a telescope. Fortunately, saner heads prevailed, as I say, and they went to the current Skylab we know and love, which brings us up to the era of actual space stations, such as Skylab, Mir, Salyut, and the International Space Station, which is the point at where I hand over to Jerry. Thank you, everyone. Stop sharing, sorry.
Good evening to everyone. I'm sure many of you will have seen me before, which shouldn't be a surprise as I'm actually given more presentations to the BIS than anyone else, going back to 1977. So I'm... come on. Right. I'm a freelance space presenter. I'm a fellow of the British Interplanetary Society and the Royal Astronomical Society. I'm also a space ambassador for the National Space Society from America, and a special associate of the Space Studies Institute, amongst other organisations. I mentioned those two because they were involved in the work of Gerard O'Neill, who I'll be mentioning. So this is Gerard O'Neill, and our story goes back to 1969, just a few weeks after Apollo 11 landed the first men on the surface of another world, an activity absolutely unique in human history. And I have to say how pleased I am to have been able to watch that live. So at the time he was a professor of physics at Princeton University, and if any of you are familiar, as I'm sure you are, with particle storage rings such as the Large Hadron Collider, that was his idea. So he was a professor of physics, and in the new semester, in the fall of 1969, he gave a special seminar to a study group of new students, and this was to encourage their interest in physics. And he posed what was meant to be the first of a number of questions that would increase their interest in physics. I say it was meant to be because, having started on the first one, they never got on to the second question. And the subject actually occupied Gerard O'Neill for the rest of his life. The question he asked them was, is a planetary surface the right place for an expanding technological civilization? And the answer seemed obvious. Yes, you do it on the Earth, or on the Moon, or perhaps on Mars. But the students went away, they did their research anyway, and the answer they came back with was no, not on any planetary surface. And there were two reasons. First one is that you will lose the sun for 50% of the time. On Earth and Mars, a day is 24 or 24 and a half hours. On the Moon, a day lasts 2 weeks, and so does the night, and you will need major power source during that period. The other thing is that on the Moon, the surface gravity is only 1/6 of that on Earth, and on Mars it's 1/3. So if you have a permanent settlement, that's going to cause major medical problems. So if you're not going to be on a planetary surface, where would you go? Well, if this is the Earth and there's the Moon and its orbit, we can calculate that orbit very accurately. But if you add just one more major object, the calculations become very, very complex. And mathematicians worked for years to solve what was known as the three-body problem. Until in 1772, Joseph Lagrange came up with a set of 5 answers. So they're known as the Lagrange points. If you draw a line between them, L1 is between the Earth and the Moon, and L2 is on the opposite side. Now normally, an object closer than the Moon will orbit faster than the Moon, so it will pull ahead, and an object further out will slow down. However, at these points, the combined gravity of the Earth and Moon means that they will rotate in the same time as the Moon does. So L1 isn't a great deal of use for us, but if this was the Sun and the Earth, L1 is a perfect place for observing the Sun, and we have spacecraft there. With the Earth and Moon, L2 is a great point for looking out into deep space, and that's where the James Webb Space Telescope is located. There's also L3 over the other side, but frankly not a lot of use. But these 3 points are unstable. If you move away, you will continue to move away. And that's why craft at these points need fuel for station keeping. However, there's also L4 and L5, 60 degrees ahead of the Moon and 60 degrees behind it. And these points, or rather an orbit around each of these points, is stable. Move away and the combined gravity of Earth and Moon will bring you back. And that orbit is long enough for you to have hundreds of structures there. So lots of designs were produced, including this one, which I think looks rather like a 1950s lampshade. But the best shapes were the torus, the sphere and the cylinder, and various designs were produced based on them. So O'Neill's first paper on the subject was in Physics Today in September 1974, and it was followed up in 1977 by his major book, The High Frontier.